Hey, what's going on, guys? In this video we are going to see how to solve a linear first order differential equation. Now in order to solve this one, first of all you have to know the standard form of linear first order differential equation. That is going to be this one: dy over dx plus p of x y is equal to q of x, and that's it. So dy, let's check the given differential equation is in standard form. To check that one, we compare. So first, if you see, we have dy over dx, p of x y, but in this case we don't have function with x, but it doesn't matter. But let's look at the other side. In the other side we have q of x, we have a function with x, but here we don't have a function with x. But how to find p of x? P of x is basically whatever the value we are adding. This is already, first of all, we have to realize that this is already in standard form, and whatever the value we are adding with dy over dx and multiplying with y is going to be the p of x value. So here if you see, plus 3 is going to be our p of x, right? So we can say p of x is equal to plus 3. So since we have the p of x, we can find our integrating factor. To find integrating factor, we use this formula, e power integral p of x dx. Now e power integral, instead of p of x, I plug 3 right here, 3 dx, and if you integrate this one, that's going to give you e power 3x. Now after we find out our integrating factor, we have to multiply this integrating factor both sides of this differential equation. So let's multiply, and after you multiply, you will get this value: dy over dx e power 3x plus e power 3x, 3 in front already, and y, right? And then here we are going to have e power 2x, and let's simplify. And here the interesting thing is this part. If you write this part, d over dx y e power 3x, and if you do the derivative of this one, you will get this back. That's the interesting thing about first order linear differential equation. So when you have this one in standard form and do this thing, the first term always going to give you the derivative of this whole thing. So therefore we can only write this one, and that is equal to e power 2x. Now we have to do the integration both sides, and if you integrate this one in terms of x, and also if you integrate this one in terms of x, let's see what we get. So first one, if you integrate this one, we already have a derivative and integration, both of them will cancel, and in the other side we are going to have e power 2x, and when we integrate whatever the power we have, we are going to divide by that one. So since we have e power 2x and divide by the derivative, so this is going to be 2, right? Derivative is 2, so we divide by that one, and other side we are going to have y e power 3x equal to this one. Also we have to write a constant, right? And the final answer is going to be in terms of y. So we have to rearrange this equation. So this is going to be y is equal to 1 over 2, and this e power 3x is going to be in the denominator, e power 2x is in the numerator, so 2 minus 3, that's going to be negative 1. So we are going to have negative x plus c e power minus 3x, and this is going to be the general solution for this differential equation. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.